equal. So let it be cos square alpha plus cos square alpha plus cos square alpha is 1. So 3 cos square alpha has value 1, cos square alpha 1 by 3, and cos alpha is plus minus 1 upon square root of 3, or alpha is cos inverse 1 upon square root of 3. Therefore, A vector makes an angle cos inverse 1 upon square, since alpha is equals to beta is equals to gamma, so therefore alpha is equals to beta is equals to gamma is cos inverse 1 upon square root of 3. Now next one is, if a unit vector A vector makes an angle pi by 4 with I cap, pi by 3 with j cap, and acute angle theta with k cap, then find the components of A vector and the angle theta. This makes angle cos, cos alpha, cos beta, and cos gamma. We have given the value of alpha and beta but not the gamma, and we know that cos square alpha plus cos square beta plus cos square gamma is equals to 1. Cos pi by 4 has value 1 upon square root of 2, pi by 3 1 by 2 plus cos square theta 1. 1 by 2 plus 1 by 4, take the LCM here, 2 plus 1. So cos square theta is equals to 1 minus 3 by 4. 4 minus 3, 1 by 4. So cos theta is equals to 1 by 2. 1 by 2 is the value of cos pi by 3. So theta is pi by 3. Theta हमारे पास क्या एंगल है? गामा एंगल is this. Now we know that A vector is equals to want to find A vector, magnitude of A, cos alpha I cap plus cos beta j cap plus cos gamma k cap. Cos alpha, cos pi by 4, 1 upon square root of 2 I cap. Cos beta, beta is the angle pi by 3, 1 by 2. Gamma is also angle pi by 3, so 1 by 2 k cap. We have given that A vector is unit vector, therefore magnitude of A vector is 1. So 1 into this. So A vector is 1 upon square root of 2 I cap plus 1 by 2 j cap plus 1 by 2 k cap. And therefore components of A vector are one by root 2 I cap, 1 by 2 j cap, and 1 by 2 k cap. Next one is, find the components of unit vector which is perpendicular to the vector I plus 2j minus k and 3i minus j plus 2 k cap. Now we want to find the components of a unit vector which is perpendicular to these two vectors. Let this vector as B and this as C. Let A vector be the unit vector with components this. Now this unit vector is perpendicular to both B and C. Therefore A dot B and A dot C has value 0. Now A dot B, xi cap plus yj cap plus zk cap dot I plus 2j minus k. X plus 2y minus z is equals to 0. Now A dot C, xi plus yj plus zk dot 3i minus j plus 2k. 3x minus y plus 2z 0. These are two equations. Now we can solve these equations by using cross multiplication method. X plus 2y minus z is 0. 3x minus y plus 2z 0. X upon y upon z upon, let it equals to some constant, say lambda. X is 2 3 1 2. सेकेंड टर्म को थर्ड से मल्टीप्लाई करेंगे. 2 into 2 4 minus third into second 1 into minus 1 plus 1. थर्ड को फर्स्ट से, थर्ड minus 1 into 3. फर्स्ट को थर्ड से 1 into 2. फर्स्ट को सेकेंड से 1 into minus 1 2 into 3. So x upon 3 y upon minus 5 z upon minus 7 is equals to lambda say. So x is equals to 3 lambda, y is equals to minus 5 lambda and z is equals to minus 7 lambda. Now it is given that a vector is the unit vector, therefore magnitude of a vector is 1. What is the magnitude of a vector? Square root of x square plus y square plus z square. If we are squaring this both sides, then magnitude of a square is also 1. So this is value 1. Now put the value of x, y, z. 3 square minus 5 square, 7 square. 25 plus 9, 34 lambda square plus 49. 83 lambda square is 1, so lambda square is 1 by 83, or lambda is plus minus 1 upon square root of 83. Now we can find the value of x, y and z. So x is 3 into lambda, y is minus 5 and z is minus 7 lambda. Therefore, the components of a vector are 3 upon square root of 83 minus 5 upon minus 7 upon, and if we take a negative sign here, minus minus plus and minus minus plus here. So these are the components of vector A. Now next one. The scalar product of vector I cap plus j cap plus k cap with unit vector along the sum of vectors 2i plus 4j minus 5k lambda I plus 2j plus 3k is equals to 1. Let this vector be as a vector, b vector and c vector. What is given? The scalar product of a vector with unit vector along the sum of vectors b and c is equals to 1. Now first find b vector plus c vector. 2 plus lambda I cap, 4 plus 2 6 minus 5 plus 3 2. Let r vector be the unit vector. Let r cap denotes the unit vector along b plus c vector. Along b plus c vector, then what is the value of unit vector? B cap plus c vector upon magnitude of b plus c vector. Now what is the value? 2 plus lambda I cap plus 6j cap minus 2k cap upon magnitude of this 2 plus lambda square 6 square minus 2 square is 4. Now it is given that dot product of this vector this has value 1. R vector, A vector dot R vector has value 1. Unit vector, dot product of A vector with the unit vector R has value 1. A is I plus j plus k dot 2 plus lambda I cap plus 6j cap minus 2k cap upon square root of 2 plus lambda whole square plus 40. Now take the dot product. 2 plus lambda into 1, 6 into 1 minus 2 into 1. Open the bracket, a plus b square, a square plus b square plus 2ab. Squaring this side, both sides, after squaring both sides, a square plus b square plus 2ab. 12 minus 4 and 44 minus 36. So lambda has value 1. Next one. If A vector, B vector and C vector be three vectors such that A dot B is equals to A dot C, then show that A vector is 0 or B vector is equals to C vector or A vector is perpendicular to B vector minus C vector. Now it is given that A dot B is equals to A dot C. We can write it as A dot B minus A dot C is equals to 0. A dot B vector minus C vector, we can write it as this, A dot B minus A dot C. Dot product of two vectors is 0, therefore one vector will be 0. A vector is 0 or B vector minus C vector is 0, or dot product is 0 when these two vectors are perpendicular. That is, A vector is perpendicular to B vector minus C vector. Now next one, show that the vectors 2i minus j plus k, I minus 3j minus 5k, 3i minus 4j minus 4k form the sides of right angled triangle. Let these as vector A vector, B vector and C vector. Let this be a right angled triangle. A vector, B vector and C vector. A, B, C. Now we want to prove that these are form the sides of right angled triangle. AC is equals to B vector, BC is equals to A vector and AC is equals to C vector. Vectors ABC form the sides of triangle. Then AC vector is equals to AB vector plus BC vector, B vector plus A vector. If they are at right angle, then their dot product is equals to 0. A dot B, 2i minus j plus k dot B vector minus plus, 5 minus 5, 0. A dot B is 0. That is A vector is perpendicular to B vector, or we can say that B vector is perpendicular to A vector. Therefore, AB is perpendicular to BC. Therefore, ABC, vector ABC are the sides of right angled triangle. Show that the points A, B, C with the position vectors 2i minus j plus k, I minus 3j minus 5k, 3i minus 4j minus 4k, points A, B, C with position vector this respectively are the vertices of right angled triangle. Also find the remaining angles of the triangle. First find position vector of C minus position vector of A. 3 minus 2 minus 4 minus minus plus 1 minus 4 minus 1. AB position vector of B minus A. 1 minus 2 minus 3 plus 1 minus 5 minus 1. BC C minus B. 3 minus 1 minus 4 plus 3 minus 4 plus 5. These are the vectors AB, BC and AC. Or if we write CA, then sign will change, minus I plus 3j plus 5k. Now we want to prove that these are the vertices of right angled triangle when BC dot CA is equals to 0. Two sides are perpendicular if their dot products are 0. BC 2i minus j plus k dot minus I plus 3j plus 5k, minus 2 minus 3 plus 5, minus 5 plus 5, their dot product is 0. Therefore, ABC are the vertices of AB, BC and CA are sides of right angle triangle. Now we want to find the other angles also. Angle between AB and AC. Cos theta is AB dot AC upon magnitude of AB, magnitude of AC. A dot B का फॉर्मूला हमने यूज किया है. A dot B is equals to modulus A modulus B and cos of theta. Now AB minus I minus 2j minus 6k dot AC I minus 3j minus 5k upon magnitude of this minus 1 square minus 2 square 6 square 1 square 3 square 5 square minus 1 minus minus plus 2 into 3 minus minus plus 6 into 5 35 upon square root of 41 square root of 35. We can write 35 as square root of 35 into square root of 35. So the answer is 35 upon 41 square root. Now angle A is cos inverse of square root of 35 upon 41. Now angle between other two sides, cos B as cos BA, BA vector dot BC vector upon magnitude of BA, magnitude of BC. BA, then negative sign and sign will change if we want the term BA plus 1 plus 2j plus 6k dot BC 2i minus j plus k. Now magnitude 1 square, 2 square and 6 square, 2 square, 1 square and 1 square. 2 minus 2 plus 6 into 1, 41, 6. 6 upon square root of 6 square root of 41. We can write 6 as square root of 6 into square root of 6. So square root of 6 upon 41. So angle B is cos inverse square root of 6 upon 41. Note it down. Now next one, question number 35. Show that the diagonals angle between two diagonals of a cube is cos inverse 1 by 3. Let A be the length of an edge of cube and one corner be at origin. Then if A is the side, let this point be A, B and C. Here y coordinate is A, here x coordinate is A and all other are 0. Here z coordinate is A. P at center, all the coordinates are A, B